Hello guys, this is Anirban Sarkar, your mentor for the data structure program. So in the last lecture, we have seen that how the array data structures are implemented, how we can take user input in the arrays, how arrays are getting traversal, and what are arrays, what are the basic concepts of array, what is indexing in array. So today we are going to see that how the arrays are basically any data or any numbers are inserted in a particular index in an array. So for that, so you can see in the last lecture we have done this code. So today we are going to see that in a particular index how we are going to take a particular value. So let us given comment to the user system.out.println, enter a number. Int x is equal to sc dot next int, and for that we are taking some index value like 4. We are taking the index 4. So suppose the array we are going to merge, or we are going to take that particular value in index 4. Okay, so let us run this and see what we get for this in the output. I guess my command prompt is visible to you all. So the user is asking to give some value 4 5 5 7 8 5. Oh sorry, I have not changed that actually. So the last videos. So let us do run this. So user is asking for a value like we are giving in the 0 index 1, in the second index 2, in the third index 3, in the fourth index 4, okay, in the fifth index 5, and we are the user is telling us to enter a number like we are entering 10. So see, we can see that in the fourth index 0 1 2 3 4, in the fourth index the value has been changed from 5 to 10. Okay, so we have changed the value by this indexing. Okay, so we have changed this value by that indexing. So let us comment out this. Suppose let us check if we can change the size of that particular array. Let us see if we can do or not. So re-implementing that, we are changing the size of the array. So let us see if it gives us an error or not. So comment down below that will it give an error or not by pausing this video for 2 seconds. So see, it will always give an error if we are trying to resize the array. As I have told in the last video, the array have given one fixed size can't be changed in the entire code in the next. So if a variable array of the array variable is defined in the method main once, it can be redefined one more time. So what we can do for this, we can create another array, and we can take all the values of that particular array in this, like for int I equals to 0, I is less than the length of the first array and not the second array. The length of the first array is n, and I plus plus, and in the second array arr2, In of the ith index, we are taking ARR values I. Suppose we are taking this, right? So let us see once what happens the next. So we are giving 1, 2, 3, 4, and 5. So array is output giving 1, 2, 3, and 4 and 5. And if we suppose if we print the array 2 up here, so what do you think? What would be the output up here? So let us give 1, 2, 3, 4, and 5. So see, this is giving 1, 2, 3, and 4 and 5, and the rest of the default index is 0. So if you are thinking, or if you are assuming, let's us insert an element in a particular index up here. Okay. So suppose this is the element you are taking up here. This is the element you are taking down here. You are taking, and you are obliged to give some of the basically some of the element in a particular in a particular index up here. So for this we need to gross up that in a particular index, in a particular, suppose this is the index inx4. So from inx4, so I is less than inx4, we have to give till inx. Okay, this is index 4 up to index 4. Up to index 4 we have to run the array. So if we are given two index, so up to index 2, with the first index it is copying the element, right? It is copying the element, and for the second one we are seeing the same, and on that particular index arr inx, like in that particular index of the arr2. Okay, arr2, we are taking that particular value, and from the I for int I is equal to inx plus 1 until I is less than n, the first array number, it will move and it will increment one by one it, and the same task we will do here. See, the same task we will do here. Okay, so 1, 2, 3, 4, and 5. So see, this is the thing, 1, 2, 6, 4, 5, 0, 0, and rest is 0. So 6 is the number which I have given for the input in the 0, 1 to second index. Okay, so let me just do one thing. Let me just clear off. See, let me just, okay, let me just run this. Just sorry, I'm sorry for it. It's a minor mistake. So user is asking for a number like 1, 2, 3, 4, 5. I've given the array number. So enter a number. So like I am willing to enter number 11. So see, in the second index, as I have given the second index 0, 1, 2, the 11 is inserted in this array. As you can see, the 11 is inserted in this array. Particularly that insertion has been occurred. Okay. So this is a way you can insert an element in an array, and if you're inserting one element, if for the beautification of the code for inserting one element, what you can do in the second array, you can keep the size n plus 1. That's it. You can keep the size n plus 1. So what will happen? Like when you're running the code, like you are giving some numbers like this. So I have given 11. So perfectly one element is extra given, right, in that index. But one drawback what we can see here, what that element is particularly given in this, but what we can see, the number 3 is overridden by this number 11. So how we can solve this? Number is overridden. So for that number could not be overridden, so what we can do is, in that particular index, when this particular index of I, we can change that particular index to the next index. Okay, what is I am saying that in the particular index you can change that to the next index. Like if I do this index minus 1, so it will not be the same as like before, it will goes to the future index, which will be a wrong thing, right? So we have taken one extra size from the previous array, as you can see here, and in the second one we are starting from the index plus 1, and we are taking the value of ARRI from the index plus 1 to the last of that. So every element in this has been copied to the second array 1, 2, 4, and 5. But the number 3, this element is not copied here. Like we have 0, 1, 2, right? 0, 1, 2. We have taken the index 2. 0, 1 of 0 till 1. The array is copying this to the new array. And in the index 2, the array copies this particular number. And from I, the array index 2 plus 1 array is starting from the third index. Okay, array is starting from the third index. 0, 1, 2, 3, third index, and it copies this. So let us see another example for this. 10, 5, 8, 7, 9, and entering a number 1. See what it does happen. 0, 1, 2, 8 has been overridden by 1, and we doesn't want this. That we doesn't want that any number which we are inserting there is overridden by any other number. So as we want this thing, we don't want the overlapping of any numbers. So for this, we have to design an efficient way of inserting an element in an array. So for that, we have to build our own logic. So let us see how we can build our own logic for the insertion of the element in a particular index without overriding that particular element. So see what we are saying. We are taking an index 2. In that particular index, this x element should be inserted. And we are taking another array of n plus 1 size, and we are giving 0 to less than index less than 2, that is 0 and 1, and 0 and 1 we are taking the array element. So in 0 and 1, what are there? 0 and 1, we are taking this array element. And in the second element we are taking this. Let us assume this. Many of you or many of the students would understand that if I plus the index element plus 2, then it will not override. So let us see in that case what we can do. 4, 7, 8, 9, 5, entering a number 1. So see what is happening. It's happening like 4, 7, 1. 8 is overridden. 9 is also overridden by 0 because no element is coming out there. Right? No element is coming out there. 9 is obviously overridden by 0. So it's of no use. Like it's of no use. So what's this thing? The by plus incrementing one another value, it doesn't help. It would not help. We have to see that any number would not override any number by the form of insertion of any element out there. So what we can do out there, that when we are seeing that last index number we are doing a plus, let us see another issue. If we are taking the element more short indexing by, so 1, 7, 8, 9, and 5, entering an element 33. See what it is doing. It is overriding the previous element of that element. It is overriding it is overriding 8 also. It is overriding 7 also. It is deleting one element of 7, which is definitely a false case, which is definitely not a case right here, right? So what we can do out here, it would all also not be done. But if we are running out this here, so what is doing, it is not overriding any other elements, right? 1, 4, 7, 8, 9, and we are giving 11. It is just overriding the second index, which index we are inserting, that is 7. So in that case, What is the thing? Because we are plus 1, that the next index we are doing, we what have to do, we have to give it from index 1 and we have to just do I plus 1. If we do that, let us see what would the result come. What result would we get? Would we are getting 11. See, now you can see at the particular element, at the particular index, no overriding is going through. We are not having any overriding element, right? In these cases, we have seen many cases. We have seen that if we are incrementing one value in this for loop after the index of insertion, then we are getting and two or three values overridden, or if we are doing one increment also, we are getting the same value overridden in that particular index, or if we are minusing this index number, so we are getting that two values or three values are overridden. So what is the solution? Solution is very simple. We have to think the logic, the how the data structures are working. If we just start the index to the last of n, this will copy the particular index of that particular value in the I plus 1 index. That will copy the value in the I plus 1. See, till the I value, see, till the I index value, we are taking the value itself. We are taking the inserted value, new value, insertion value on the particular index. From the next index, we are taking value of the array second, but it is the same index where the value resides with the previous value resides in the first array on the ith place, on the same place. It doesn't change. The change is in the second array. That's why we are incrementing the values of the second array and not the first array. That's why starting from the index plus 1 doesn't help. If we are doing so, we are overriding the value. We are overriding the value, which will doesn't help you out in the insertion of element. So by this algorithm of Java or with this algorithm, we can insert new values through two arrays, right? So this is the insertion of new element. Like if you are inserting two elements, like if you are inserting another element, like this is the element and another element you are inserting. If you are inserting two elements, then simple plus this by 2 and take another and take another one, another index, like you are taking this index 3, right? You are taking this index 3, and similarly array 2 index 2. In the next index you are just inserting another index. That's it. And just changing some for loop here. What you are required in this, you are changing some of the for loops here. You are starting from the index 2, from that particular index, but here just plus 2. Let's just see it can override or not some of the factors. Maybe it can override or not override. Just comment down below. See what it is here. 1, okay, 4, 1 is giving here, then 5, then 5, then 6, then 7. So we see, we can clearly see, if we are carrying out the same process or the same algorithm, it is impossible that you would get any overridden solutions. So by this you will not get any overridden things. So by this method, you can insert in an array. We have discussed these things. We have discussed the procedures. We have discussed all the possible outcomes. We have discussed all the possible errors. We have discussed all the possible things, that how we can solve the overridden problem or how we can do insertion efficiently. So you can insert element in an array by this process. So thank you for today, guys. In the next lecture we would see the deletion, how we can delete an element from an array. I guess it is clear today. I am quickly giving an overview of this, that we have seen the how, what are the problems of insertion of array, what are their problems, how there are overridden are there, how for loops are implemented, and how sorry how for loops are implemented for arrays, and what are the drawbacks and what are the overridden problems, how we are giving input and how it is coming overridden, how it is overriding the solution, and how we can overcome the overridden, how the logic are build ups, as I have showing you the what are the problems if you are coding like that, what it can comes to your coding problems. So if you follow these instructions, how if any overridden problem would not come in your code. So thank you for today, guys. Let's end this video today, let's end this lecture today, and from next lecture we would see how an element is deleted from an array, and after that we could show where we can see the insert, we can see the searching and the sorting problem in array. Thank you for today, guys. Let's meet up the next video. Thank you.